Hello everyone to the Let's Go with Turso series. I am Meet and in this fourth video of the series, we'll dive into setting up a Go project using LibSQL as a database and explore how to use SQLC to generate schemas and queries in Go. SQLC is a tool that compiles SQL into any native programming language code. If you are familiar with Object Relational Mapper or ORM, then SQLC is the opposite tool of that. ORM generates SQL code from the native programming languages, whereas SQLC generates the native programming language code from raw SQL. There are two types of developers here. One who love the native programming language or hating to write SQL, and the other not so hating the native programming language but worried about type safety and security issues or loving to write SQL issues. Both are valid and appropriate for their own use cases. It depends on the project and goal in the developing the project. I'm just going to demonstrate how to use SQLC with Golang and LibSQL database in this video. Let's get right into it. So as said, SQLC is a tool that generates any native programming language code from raw SQL. There are a limited number of programming languages supported at the moment. Others are being added via plugins. The steps we take to generate the code in programming language with SQLC are threefold. So the first, as obvious, we need to write SQL queries to create tables, which are called schema, and queries to retrieve and perform operations on those data in the tables. We can call queries. The second step would be to generate the code in the required programming language with SQLC compiler. And finally, with the generated code, we can integrate that and use it with the existing or the new code in the project that we have. So SQLC is itself written in Golang. The supported languages at the moment include Go, Python, Kotlin, TypeScript, along with the support via plugin for C Sharp and Ruby. Give a star and show love to the open source project on GitHub to SQLC. I'll put the link in the description as well. The documentation for SQLC is pretty neat and extensive. So let's get started with the Golang application. Let's initialize a new Go project with the go mod init command. We can name this as a convention with the version control provider's name, the user or organization name, and the repository name. Once initialized, we can install the SQLC tool as a binary or with go install command. Since SQLC is written in Go, it will be a Golang package, and that makes it easier to install with existing toolchain that we are developing the project on. So once SQLC is downloaded and installed, we can type in SQLC to verify the proper installation of that. Since LibSQL is like SQLite, we can mimic the installation and set up step procedures for LibSQL as well. We will need to configure the project to make sure the SQLC compiler understands where to look for the SQL schema, queries, and where to spit out the generated code. So there is a sqlc.yaml file that is created, which will have key value pairs, like as a configuration, set up the file locations for queries and schema, and the output folder. We will call schema file as schema.sql and query file as query.sql to keep it simple. However, I'll change the name for the output folder as data to make it clear, and uh, we can change it to whatever you can prefer over here. Once the configuration is completed, we can head out to crafting the, the schema for the project. So this will reside in the schema.sql file. For demonstration purposes, let's create a users table, and let's have a fields like ID serving as a primary key, username as text and not null and unique as constraints, password as text and not null, which will be the constraint. Let's add one more table called post and have a ID as a primary key, title as text, body as text as well, and user ID as foreign key that will reference the ID in the users table. So that is all that we have in the schema. Now we can go ahead and write the queries. This will be used to interact with the data in the tables, the normal CRUD operations or queries that we have in the project. In this case, we will have queries for creating, fetching, updating, and deleting users, or also hosts that we have created. We will have also some other special queries which will require some joins and other SQL commands. So let's start by creating our queries. First, we will create a simple query that will fetch all the users. The typical select star from users where ID is placeholder. Now we need to add a metadata about the query. They call it query annotations. It's just naming the query that the name of the function will be used in the generated code. We will also need to provide the command that will determine the action that is performing. Like for instance, creation will have the command exec to execute. Exact result to return the inserted value after the execution. 1. Just to return the single record. Many to get multiple records, and so on. You can check out the doc for more such commands. So moving ahead, now we can create multiple such queries. So the second query we can write is list users, which will return many instances of uh, user records. So select star from users where order by name, username, and we can do all sorts of things here. Then we can move to other CRUD operations like create user, which will return just one instance of that created record. So it will insert into users the username, password, and bio, which are the required fields in this, and with the placeholder values, returning the entire thing that the query returned. And the update user, which will update the existing users, and this will return one instance, one record of the user record. So it will change. We can change the bio where we have provided the ID and return the updated user. Then we have the delete user, which will just execute the command because we don't want the deleted user. So delete from users where ID is the placeholder. And then moving ahead, we can go create queries for post table which we have created, which have the fields like ID, title, body, user ID as a reference in the users table. So let's get ahead and start with the get post, which will just return one post record. So select star from post where ID is placeholder and will limit it to one. Then list all the posts, which will return many posts, and then select star from post where we can order it with ID. Then create post that will be used to insert post record with the title, body, and user ID as the placeholder values. Then update the post with the title, body, and ID. So we can change the title and body, but we have the ID as a reference. So we'll return the updated post and the delete post, which will just delete the post. So we now have the schema and now we have the queries as well. So now what we can do is with the SQLC.yaml config created for this, we can generate a Go code for this equivalent SQL. So as you can see, the data folder has created the db.go file, which is just used for configuring the database what we are using, and models.go is the equivalent structure of that schema that we have created. So you can see there is a user structure with the appropriate fields in that, and post structure as well that we have in the schema defined. And similarly, we will have query.sql file that we created, and it will have query.sql.go. This is generated from SQLC from those equivalent queries. So it becomes really easy for us to use these functions and structures to perform CRUD operations or any other operations in Golang or any other programming language for the sake. So moving ahead, now we can install the libsql Go package, which will be used to connect the LibSQL database and execute queries and run the database using a Golang application. So we'll start with the installing that package. It is LibSQL client Go, and this should get it up running inside the Golang project. Now we'll create the program to run this LibSQL database and create operations on database with SQLC generated code. So first we'll open the database using sql.open. So SQL will be fetched from the database slash SQL library to perform any operations on the database. And we'll need the driver name and the uh, address. So we'll import all of the required packages, which will be the data is the uh, package that we are using, that is a generated code from SQLC. We'll import other packages, that is go libsql, that we just installed to connect to the libsql database, which is running locally, which will be a libsql driver that we imported, and that will be connected to the localhost 8 and the port 8080. So that reminds me that SQL is not running, so let's run that, and this should serve the libsql database at localhost and the port 8080. So once we have the DB connection up and running, we can log the errors out if we fail in the connection procedure, and then we can have the context setup, which we will require to operate the migrations from this database as well. So db execute context ctx, and here we'll require a go embed thing, because this is a macro that is used by SQLC to like kind of perform certain operations just before this. So embed is one of the features. You can look up all the procedures that are in provided by SQLC in the documentation, which is a really good nice documentation to go through. So go embed will basically take in the contents of the file and convert it, will cast it to a string. So in this case it is schema.sql file. The contents of schema.sql file will be populated into a variable, which will be so ddl. So data slash schema, since we have created the schema file that will be used to populate and create tables on the database. If the tables are not created, that's why we have written create table if not exist, so it doesn't error out if we try to create the already existing tables. So embed will use to generate those SQL strings and execute it on the database itself, and we'll log those error out if we get any error messages here. There we could change a little bit depending on how we use it, and now we can get it to the data.new, which is the data is a package that SQLC has been generated for us. So data.new.db will create a new instance of that DB connection, and from that we can uh, access the queries that are from the generated code. So queries.list users will list all the users that are there in that DB. So we'll print out all the users. So this is the code for a basic setup for getting SQLC running with libsql in the Golang application. So what we'll do is we'll run this program and see what output we get, because we have not created any records, so it will be empty, and that is empty. So we can verify that it with the previous tutorials that we have shown, that is the data file has this SQLite file. So we can see that the schema indeed is populated, which means that we have populated the database with the schema, but we have not inserted any data. That is fine. So next step will be to get the data into this database. But once we'll check it in the Turso DB shell as well to get it clear that we have the schema but not the data, right? Because we have populated the schema using that script that we ran, but we don't have any data to show yet. That will be the next step, and let's start with the next step, which will be to insert the users into the table. The user payload will be a structure that we have created to insert like username, password, and bio. So this will be required. So we'll pass in those, and once that is done, here you can see null string because this could be null. Bio could be null for the user. So there are different types, which is the really type safe code for running applications. So once we have the parameter set for creating the user, we can run the create user function from that SQLC generated code, and this will create the user from those parameters. And as usual, if there are errors, we'll log those out, and this will have the newly inserted user, and we'll again list the users from this command. So as you can remember that we have created list create user will return the newly created user as 1. So this will be, so we run the command program, and we can see that there is indeed one record being populated, and there is one record for the users table. We can see from that, and let's try to add a few more records just to see if it gets populated, and it should work real simple that ways. So we'll create a test user and run this program again, and as you can see that there are 2 users now, and yeah, so that is, so let's see, there are the 2 users created from the database. Let's add the third record, and we'll run the command, run the program to see the third user being populated. So there are now 3 records for the users table. This is how you create the basic level of SQLC integration with LibSQL database in a Golang application. So now let's try to uh, work with the queries which are not users. Like we have looked through the procedure for executing other queries will remain similar, right? Like you can update the users, you can delete the users, those will remain same. So let's look at a few things which are a little complicated, right? So the other thing that could be complicated will be create a foreign key like uh, table. In this case, it is post. So we'll create a post parameter, post record. First, we'll need to create the uh, object for the post. So like the parameters that we require to create the post table. So that will be title, body, and the user ID. The user ID we have created in the previous query, that will get the ID out of that and create the post from those provided parameters. So create post is the generated code from SQLC. This will be used to populate the post table now. So we'll usually do the procedures for logging those errors out, and this should be populating a single post into the posts table. So let's run this query. Let's run this program to see that to test the query. And so first we'll check if there is any post in the table. There shouldn't be any posts. So once we select star from post, so there should not be any records in this table, right? So there are no posts in the table, but once we run the program that inserts the post, we can see it has logged that one record that we inserted. And let's check out in the Turso DB shell, and it has indeed populated one record in the post table. So Now add let's add a query which will require a simple join, that is select star from posts, join the users on post.user id is user id. So post table had user id as a foreign key, like a reference to the users table, but we don't want user id to be the uh, the parameter that we want to select the post from. We want the username as the parameter that we give into it, and we get out all the posts from that for that particular user with that username. So this is what we write the query for, with the name list post user, and it will return many posts if there are for that. So it will be the form of lists. So let's create. So I've created. So let's generate this. This will be to generate that helper functions that we'll use. And so I've written the code for this, which will be, this was previous one, and this is queries dot list post by user. So we'll pass in the username. As you can see here, I have created author, the last inserted the author username. So the user. So let's hard code it to, let's say, test. So it makes it clear test 2, which will be the actual username instead of doing that. And once we have that, we can run this program to check if that there is returning the posts that are, and indeed it is returning the posts that are for that user. And let's add one more post to check if that is working correctly or not. And this should return two posts, a post and another post from test2 there. So that is indeed working fine. So that is how we do SQLC integration in libsql. Thank you for watching.